r pi minus, according to this identity, r Laplacian of pi minus 2 gradient of pi. And if I plug this into here, let me see, did I get this correct? If I extract the r component, let me see, did I get this correct? Well, let me see. I think I have it correct in. Okay, it's rather complicated. Maybe that's why it took me a while to figure out my note. So if I were to extract the r component of this, which is what I need to do, the r component of this, r component would come from the r component of this, okay, which is the gradient is actually partial r, divergence of r pi, okay, and then this would just give me r Laplacian of pi. For Laplacian of pi, if I were to solve this problem using the divide, not this equation, if I were to let's cross out this equation, okay, so that I will point to it wrongly. If I were to use the divide potential approach, this is just plus r k squared pi. Okay, this term gives me that, and then I will have 2 partial r of pi. Okay, and the divergence of r of pi. If you remember what that is, that would be equal to having 2 terms, I believe. Let me see. Will give me something like divergence of r times pi plus r gradient of pi, using the chain rule, right? What is divergence of r?
1, 2.
What is that?
2.
What is that?
It's 3.
3. 3. Okay, looks like 3 to me. So it should be 3, right? 3 pi plus r, the gradient of pi should be equal to that. Okay? So that should be true. Okay, that should be true, and then I would have this being equal to this is this term over here, and then plus partial r, partial r pi, right? That gives me 2 terms, and then minus 2 partial r pi. Okay, that would be the total terms. And so the 3 and the 2 doesn't cancel, unfortunately. But you can show that this actually can be written as, let me write it up. Okay, let me write it up here. That if I write this as something like, let me see what I should write it as. Partial square partial r pi. Partial square partial r square r pi. And this is equal to okay. If I apply the chain rule to this, I will get partial r pi plus r partial square partial r square pi, right? But it still doesn't cancel. If I apply the chain rule to this, I will get 2r partial r pi plus r partial square partial r square pi. And what I'm trying to do is that this thing here can be written more succinctly. I'm not successful in doing that, but it can be written more succinctly as such. Okay, it can be written more succinctly as such, as given in the textbook, that HR will be equal to 1 over I omega mu r squared r pi m plus k squared r pi m. Okay, if I have successfully extracted the r component of this and went through this algebra correctly, then the r component of this thing will just be equal to that equation over there. Okay, I have a mistake that I need to sort out over there. You're not canceling. But what I'm trying to show is that this partial square partial r square gives me that, and then it's finally equal to the total sum of this mass over there. Okay? And then ER is equal to okay, maybe you can take a break now. And then you can figure out for me where I went wrong over there. Why I'm not getting this to sum up to be that. I just got it the other night, I thought. Okay, but I cannot reproduce it here now. Let's take a short break and then we'll come back and continue again.